Good morning, good afternoon, and good evening, everyone. So today I'm going to be continuing this little project of mine that I've been working on for a while. I haven't really gotten to finish it, um, but the idea is that, well, if we're given three circles in 2D, are we able to find a circle that touches all of them that's tangent, right? And so from here we were able to discover some relationship, right? So here's the problem. Can we find an equation of a circle, an outer circle, given any three non-overlapping circles or spheres that goes around them, that touches them, and closes them in 2D and 3D, right? So here we were able to look at this sort of relationship in a way. We're saying that, well, the center of my inner circle and the center of my outer circle, right? And if we look at their radiuses, well, here we say that, well, given my, okay, I said C naught. C naught is the center of my outer circle. If we get the distance of those two, we'll get this yellow highlighted thing. And it's the same as the radius of the outer circle minus the radius of that inner circle. So that's how we were able to derive these formulas. And then from there, well, we just use the distance formula in 2D. So that's just a short example. If let's say one of our inner circle was at the center of the origin is the center. Um, it's a unit circle. That was just an example, and so we were able to derive this idea, right? So this is just the distance formula of the two centers, and we're subtracting that, or no, not we're subtracting. We're equating that to their distance of the radii. And so we do it thrice because we have three inner circles. We do some expansion here, so some messy, very, very messy algebra. So we just expanded that. We subtracted one from two, and then we did the same. So here's the linear. And actually, after we subtracted that thing, surprisingly, we're able to get a linear equation. We're able to get a linear equation. And we do the same for one and three, right? We just switch three, two and three, because it's literally the same thing. And then we solved for this system where we got constants, right? And then from there, well, these are, yeah, x1, x2, y1, y2, r1, r2. These are the center, the coordinates of the center of each inner circle, as well as the radii, right? And then we were able to come up, well, yeah, we just kind of substituted some letters here. 'Cause let's be honest, it looks messy. And then from there, well, we were able to get a linear equation. We're actually able to get two linear equations, right? So that's surprising. And then from there, well, we just did some simplification. We got a function y of r, where if we plug in some radius, we're going to get y, right? And if we plug y of r, now we can use that to find our x coordinate of that outer circle. And then from there, we can plug both of them in to get r, or the radius, right? And so there are some numbers that worked here. I did try to test some of them. And one of the case was that if my r, my big R, my radius of the outer circle is greater than 0, and let's say if my radius of each inner circle is not equal, then my R survives. But in other cases, my R disappears, so it makes it easier to find some formulas here. And yeah, we were able to get these for my X and Y. And there we go. We have our R value. Yeah. So this is one of the test cases I did. But overall, it's a really long formula. Um, yeah, it is a really long formula. So let me actually show what that looks like. Or, well, technically, okay, here's the thing. I still don't know how to like move things around in Desmos. But we're gonna we're gonna try our best here. So if we look at my numbers, so for my inner circles, I think it was, yeah, x1, y1, r1, 60, 0, and 10, x2, y2, r2, x3, y3, r3. So these are my three inner circles with the centers as well as their radii. And then I plugged in everything for the constants, got, and then I got the center as well as the radius of that outer circle. So let me just plug that in. So this is 6, what was it? X equation of a circle. X minus 60 squared, right? Because that's the center. The x coordinates, the x coordinate of the center. For my y, what was it again? It was 0. I was gonna write it as is. And this is equal to my radius squared. So 10 squared. Can I see it here? Oh, there we go. Uh, okay. Let me just type them out before I share my screen. Then we have x minus negative 10. So this is just x plus 10. And then I think it was y minus 0. And then this is equal to, again, 10 squared. Yeah. And then lastly, we have another one, which is uh, x is 0. So here, what I'm just doing is I'm graphing all of the inner circles. Square root 300. This is equal to 10 squared. Okay. And then let me just graph the final outputs. I'm going to graph the exact ones, the exact values. So my outer circle is x minus, what is this? X minus this number. So I'm just going to do plus 10500 divided by 70 square root of 300. It looks like a line here. That's Then I add it to my y minus 20. Oh crap, no. This is my y value. Oops, my bad. We're gonna put that as my y. Then my x is minus 25. And then this is exactly 10 plus square root of 1, 300. I'm gonna square that, right? And there we go. Let me just share my screen. And so here I've plugged in the numbers. How do you add like the notes? Can I add notes? Oh, I can't add notes. Yeah, but here you can see that this purple is the outer, and then the red, the green, and the blue circles are the inner, and they're not overlapping, and they intersect the outer circle exactly once. What else? Can I add notes? I want to do that. I can't add notes. Anyway, so that's that. And oh, yeah, I should have just put the screenshot here. Anyways, yeah, because I don't know how to. Okay, I'm just gonna do this. Like I'll do a screenshot of this thing. 'Cause I know I can't like. Okay. And then let me just go to here. So what I'm actually gonna do in this video is now I'm gonna make it 3D. I'm gonna solve it. I'm gonna make it 3D. Um, okay, let me. Oh shoot, what did I do? Oh, let me do this like that. Oh, there we go. Nice. Let me just. There we go. Much better. 'Cause then, oh shoot, oh, I can't see. Uh, that's not fun. If I do this, I put this down. Okay, there we go. And then, yeah, yep, there we go. So we know that it works in this case. I mean, we can try something else, right? We can try this. If we were to do something really basic, like let's say one is the unit circle, we can also do that. It would still work, I think. Let me actually try one more example. I'm gonna do like what, two of them? But this time I'm gonna make my radius. Yeah, let's try another example before I start doing 3D. My other example would be something where the radii are not equal, so that this r survives. Um, yeah, we'll see. We'll see what happens actually. Let me try. So if I do, okay, testing formulas, or let me just do examples. There we go. Also, let me change this to 1, 2, or 3. Just that I as a placeholder. Okay, let's try another example here. What if, let me go to my share. This one I'm just gonna pick out of random. I'm not even gonna like, I'm just gonna pick it out of random. Let me just do a new Desmos. Or maybe I shouldn't. Maybe I should just like, how do you even save graphs? How do you do this? New graph. I think it's not this. Can I like put notes? What if I do that? Oh, there we go. And then this is first example. Okay, okay. And then I put this. No, I can't. Oh, that's nice. And I can move it. Great. Decimals. Okay. Ah, screw this. I can't do it. Okay. What if? Oh, there we go. Now I can move this thing. Yeah, we're gonna do it manually. Yeah, let's do it. Oh my goodness. I should have just, and then I drag this here. Okay. Okay. And then we're gonna do a second example. And this one I'm not super sure what it's gonna be. I'm just gonna pick like points at random. Let me do this. Okay, just to take it out. I don't know. My x is gonna be, let's try a unit circle. Why not? Let me do a unit circle. So this is a unit circle equals 1, right? That's extremely small. And then maybe one with like, I don't know, maybe one here as the 4 as their center. You do that. You just move it around. Let's try that. There we go. I moved it. And then maybe one that's let's make the radius a bit bigger. I'll make it like what, 4? There we go. See what happens if we do that. Let's see if there's a circle that will actually help us get this value. And then we try like, I don't know. This is really random. X2. How do we make it not hit? Plus 8? Oh, that's too far. Let's see. Equals 1. Where is that? I think that's like super far. Oh, there you are. You're at the bottom. Oh yeah, because it's minus. I don't think there's a circle that's gonna intersect that. But we'll see, we'll see. We'll see what happens. Okay. So these are really just a bunch of random points. I have no idea what the circle will look like. Let me see. So if we go back to my example here, and if we were to copy this, so I have three circles again, right? Am I sharing it? Okay. Three circles again. But this time they're like completely different uh stuff, right? There we go. That's better. Oh my goodness. Uh oh shoot. Okay. How do I oh, okay. There we go. So my X1 or my first circle was the origin. So basically everything here was 0. And then this was 1, right? So this is a unit circle centered at origin. Uh for my next circle it was 404. 404. Well, not 4 in this case. It's actually 2. Because I put 4 and then, yeah, 2 squared. And then my third one was 2 and 8. So this one's 2. This one's negative 8. Because it's minus negative 8. And then this one, my radius is 1. Then we'll see what we get here. So here I just put like a bunch of random numbers. Um, okay, let me test out my formulas. First thing I'm going to do is try to get all my constants down, right? So I'm going to say A1, B1, C1, D1. So what are these? Well, if you were to look at my cheat sheet, okay, I'm just going to take a screenshot of this for myself. So yeah, this is the hassle with, I don't know if you guys can help me improve the formulas, but this is really a hassle because I have to look at the, I have to like make a reference of me just like looking at it. But yeah. Okay, so my first one was x1, x2. So what is this? X1, x2, so that's 0 minus 4, that's negative 4. My B was y1, y2. Okay, I might split the video just because I think the example's too long, maybe. This one, y1, y2. Well, that's just 0. My C is, what was my C again? I think it was R1, R2, R sub 1, R sub 2. Yeah, this one was 1 minus 2, that's negative 1, right? And then my D1 was, oh shoot, this one's 1/2 of everything squared. So this one was 1/2 of everything squared. R sub 2 squared, R sub 1 squared. And I think it was plus, right? Yeah. And then this one became x1 for some reason. Okay. I wish I had like code to just do this, but anyways. I did try coding it, but I don't know how to like get the exact value. It just gives me approximate solutions. So might as well just do it this way. This one gives me 1/2. R2 squared, what's that? 2 squared, that's 4. R1 squared, that's 1. x1 squared, that's 0. x2 squared, that's 16, because 4 times 4. y1 squared, that's 0. And then, yeah, these are all just zeros. So we just have minus 16. And then this should give us, if I'm not computing it wrong, I have negative 13 over 2. Now, can I... Oh, let me just do this. 6.5. Okay. Or actually, screw it. I'm going to leave it as a fraction. I'm scared because something might happen. Okay. Um, yeah, now we've got everything there, I think. Do we have an E? I don't think we have an E. We don't. Okay, now we do our A2, B2, C2, D2, and then we go directly to our formulas. So A2, B2, C2, D2. What's this again? Crap, I have it in my screenshot. X1 minus Y3. Oh, so this one's basically everything from 2 that became 3. Then what was it? R1 minus R2. So this one's R1 minus R3 in this case. Yeah, and then I have my D2, which is basically all of these, but replace it with R sub 3. Yeah. Okay. And then from there, okay, let me just plug everything in. So my R sub 3 squared is 1. My R sub 1 squared is 1. Looks like 1. 1 minus 1, well, that's 0. My x sub 1 squared is 0. My x sub 3 squared is 4. It's 2 times 2, or 2 to the power of 2, it's 4. My y sub 1 squared is 0. And lastly, my y sub 3 squared is 64, right? Okay, I hope I got that one. Yeah, so here I just have 0, minus 4, minus 64, minus 68 over 2. I got negative 34, should be. Yeah, because this is negative 68 divided by 2 is negative 34. And that should be it, right? What else? Oh yeah, my A2, B2, C2. Yeah, I'm just checking if I actually got it, because I feel like I'm messing something up. I don't think so. I'm still good. Okay, A2 is x1 minus x3. X1 minus x3 is negative 2. Y1 minus y3. So this is plus 8, right? 0 minus negative 8 is plus 8, or positive 8. R sub 1 minus R sub 3 is 0. Okay, and then from there we can just check. What was it? Now I solve for y of r and x of r, right? So I solve for y of r, and if I remembered, I don't remember my formulas. That's why I put them in red because I can't remember these. Um, okay, let me do that. Y of r is A2C1 minus A1C2, A sub 2 C1. So here I'm just like putting all of the constants together. A1, C2, and then so that's a constant, R, plus A2, D1, and then I think this was A1, D2, right? And then I divide all of that by A2, B1 minus A1, B2. Okay, and then from there I actually get, oh God, I get, let me see. Can I like, I'll put this down maybe. Okay, I'm putting it down. So A2 is -2. So this is, okay, I'm just gonna plug it in. C1 is -1. Yeah, so here I'm just reading off of this whole thing. A1 is -4. C2 is 0. R. Okay. Yeah, now this might be an issue because my R will not be canceled unless something happens, right? Yeah, we can't really tell, to be honest, or I can't tell at least. -2 here. So this is just to play it safe. I'm just plugging in everything. D1 is -13 over 2. Ooh, this becomes 13. A1 D2 was that? -4. D2 is -34. There we go. And then I divide all of that by A2B1 minus A1B2. So -2. B1 is 0 minus A1B2. A1B2 is -4, 8. Okay. So let me just quickly solve these. Well, this becomes nothing. This becomes nothing. What else? This becomes 2. This becomes 13. This becomes minus something. I think it was, what was it? 136. And then so minus 32. So this becomes positive 32, right? So here I have 2r plus 13 minus 136 all over 32, right? And then I get 2r plus 13 minus 136. There we go. And then from there, now I have this thing. Okay, cool. Now I plug that in, right? I can safely plug that one in. Um, yeah, this one should go to my x of r. Yeah, I can't think of any more or any other way to simplify. Yeah. So that's the thing, right? My C1 and my C2, if they're not equal, then R will survive. That's the one I'm trying to say. Now I'm trying a case here where they actually don't survive. So bear with me. Okay. And then from here, what do I do now? Well, I plug it into my X of R, right? That's the next thing I have to do. So my X of R, yeah, actually, let me take this out. Taking out all the computation if I can. At least it's in the video, so no worries. There we go. Now my x of r is something. What is this? What's my formula again? Oh, here. So now my problem here is that my x of r has to include my y of r. And so my only hope is to get b1 to 0 or something like that, right? So yeah, I'm like taking a screenshot from behind just to get a reference of what I'm actually looking at. Okay, so we have C1R. Oh, that's also another thing. Plus D1. And then this was B1. Wait, why do I have a Y? Y of R. So the thing that I got for Y of R, A1. And if I plug in everything there, what's my C1? My C1 is -1. So here I have -R actually. Then I have D1. My D1 is minus 13 over 2. So this is minus 13 over 2. Minus B1. My B1 here is 0. So there we go. Now we get to cancel that thing. And then this is over my A1. My A1 is -4. Okay, so I can do this. R plus 13 halves over 4. What else can I do? I can say, well, this is 2R over 2 plus 13 over 4, 8. So this is 2R plus 13 over 8, right? And now from there, I can actually completely solve for R. Because now I have one thing, right? Now I can solve for R. Okay, so how do I solve for R? Where's my thing? Those are not values yet, so I'm just gonna wait onto that. Now to solve for my R, I want to use my last formula here. There we go. I could just use any of them. I'll probably just use x1, y1, right? I'll just plug them into the first equation and I should be able to get it. Because here we're just trying to find some R value, right? So let me take a screenshot. Okay, so let me just do this. XR minus, and I think this was x sub 1. And I square that. My y of r minus my y sub 1 is equal to my r minus r sub 1. And then voila, now we can just plug in everything. So here we have 2r. Yeah, now this is the computation. So here my x1 is 0, right? This is just, I can just write that, 0. My y of r is, oh, I just reversed it. Oh my goodness, this is 13. This is 8. And then here my y of r is this. Minus y1. Y1 is 0. Yeah, so here I'm just using the unit circle. This is equal to my r minus 1 squared. Right? And then from there, we can just completely solve for some of these values. So let me just do that. This is one equation and we have one unknown, so we can find r. Now the thing is, how in the world? God expansion. Okay. Um, I don't like this. Anyway, I'm trying to think of a way to make it easier, but I guess I just have to go through the computation. But here I should get some r, right? Let me just go through it. So this is, we do this twice, right? God, I might have to do a next video on the 3D part. Um, okay, this is fun. And then from here, well, we actually just get, how do I simplify? I want to make it nice to look at. Let me do 1/8 of everything. Yeah, and then this becomes 2/8. So it becomes like what? 2r/8. So this is 1/4 r/4. Oh, there we go. This looks better. I'm gonna write it this way. Okay. And then from there, I should be able to get it. So here I should get, uh, we just do FOIL. 4 times 4, 16. Uh, what's this? 13, 8 times r to the fourth. Oh, it's just, yeah, it's just 13r 32. And I do it twice. And so I get 13 plus itself. That's 26. Then from there, I just get, what's this? Plus 13 eighths squared. What's that? What's 13 squared? I don't know what that is. Oh, 169 over 64. And there we have it. We have a nice looking formula. So that's the first part. Oh God. It is a quadratic formula. Okay. That's one. Two more to go. Actually, why did I do this? This one's easiest. So this one is just r squared minus 2r plus 1, right? So let me like put that in the side here. And I'm just gonna like drag it when I'm done. Okay, I'm gonna add it to this one now. So this is 2r. Is there a nicer way to kind of organize this? I can do 132, 1 over 32, but like this. And then I could just, well, separate it. So I get like what? Oh, uh, r over 16 minus 123 over 32. And I do it twice. And then from here, I get r squared over 16 times itself. 256. And then this is minus 123, 32 of this. Can I? Oh, shoot. Can't do it. So this is 132r. 32 times 16. I get 512. And I do that twice. This is 246. God, computation's a mess. Can I simplify this? I get 123 over 256. Oh, look at that. Got something of 256 here. And I think, okay, cool. Oh, I could actually simplify this other thing. I just realized. Because I was like, wait, there's a pattern. This is 13, this is 16. And then I'm thinking I could still simplify this, or no, probably not. Yeah, no, I can't. Yeah, I can. Okay, you have this. And then lastly, I just square that thing. So I get 32 squared, 10. Okay, so that's me expanding. Uh, can I just copy and paste this? God, long computation, very long. Okay. And then from here, we get, well, that thing, right? So here, what do we notice? It's actually just a quad formula. Uh, yeah, so after expanding, that's what we can tell, right? Goodness me. Okay. How do I solve for R here? Okay. Let me find a common denominator, right? I could do that. So this is okay. So what I'm gonna do here is put everything of each like degree to where it needs to be, just to kind of keep it organized. Uh, let's do R. Yeah, and then plus this, the constants in -1 equals 0. There we go. Let me just do this. Just to kind of keep it organized. Um, there we go. Not too shabby. And then this becomes plus. This becomes minus. Okay. And then from here, let me just like do one by one because I don't wanna I don't wanna gas myself. This becomes 16 r squared 16 plus r. Or no, what I can do is I can factor out the r squared here, right? So this becomes 1 over 16, 1 over 256 minus 1 r squared, right? Because I just factored out my r squared. And then from there, I could just denote this as some value a or something. I don't know. Or I could just find their common denominator. If this was 256, well, then this would be 16, right? Yeah, because I just have to multiply 16 twice to get that value. This one I leave it. This one is 256 over 256. So I get 16 plus 1 minus 256. Negative 239. So I get that value, right? Can I simplify? Oh, that's the exact simplification. Okay. Okay, cool. And then from there, let me just do the same thing. I'm gonna factor out an R here. Goodness me. Then I do a quad formula. Okay. Oh, goodness. Okay. So this one becomes, I just realized I hate solving. 256. Yeah, I'm gonna make a new video after this part just because it's too long. Computation wise, it's really long. Okay, I think I was able to factor. Okay, that's good. And then, yeah, I'm gonna do the same thing. So this is 256, right? 16. So 13 times 16 is 208. So I do 208 here. And then here I do 256. Then this one's twice that. This is 512. Then I do a subtraction. 208 plus 123 minus 512. So negative 181 of this whole thing. There we go. Then this is R. Yeah. And then I just make it a plus, right? $181. There we go. And then that's it. Okay, here I'm just trying to make it clean. Oh, and then after I do this, I think I can factor out 8256 or just divide it by itself to get the 0, maybe. I might try doing something like that just to make it clean. Okay, and then for my last term, I do this. It's just a constant. So we can just say 64. Is that common denominator? It is. Oh my goodness. So this could be 1024, 64. Can I wait? Oh, I can make them all into a 256. Should I just do that? Actually, I kind of don't need to. I don't need to. So 64, I just multiply that by 16. Lucky me. Again, nice number here. Then this is 1024. And then from there I get, I don't know, 15129 minus 1024. And I get 16809 divided by 124. Now is that a number I can, oh shoot, it's not. Oh goodness. Okay, so I get that number. So let me just, I think what I did here is I added, right? Yeah. This is now equal to 0. So I do a quad formula. Oh, let me simplify. Before I can divide this by 4. Let me just do that. Oh shoot. Or actually, it shouldn't be that bad. 420. I'm gonna risk it. This should be fine. There we go. And then now I factor out this whole thing, finally. So I get this. There we go. Now I multiply them by 1/256. That was my plan, right? Can I still simplify, make it cleaner maybe? I don't think so. Yeah, I don't think I can do it anymore. So maybe I just have to do a quad formula. Negative b plus minus square root of b squared minus 4ac all over 2a. Don't ask how I memorized that. Negative b plus minus square root of b squared minus 4ac over 2a. Okay, so this is just my r, right? And once I get my r, I can actually plug it in here and then get some x and y value. Okay, don't worry, we'll see the result in a while, in a bit. So this is, let me just do it step by step. I don't want to mess up anything. This is 181 squared, 32761 minus minus is a negative. 4 times 239 times 4202.25. God. 4017. Oh, so we have no solution. Yeah. So we have no solution in this case. I just realized. Yeah, because this is an imaginary number, so it's not possible. It took me a while to get to this point. Anyway, yeah. So yeah, we got that. No solution because this is negative. There's no R value. And it also doesn't look realistic, right? Let me try an easier one. Maybe something that will work. Maybe you can do like, yeah, that was too bad. Did all of that for nothing. So that one has no solution, right? Uh, yeah, because there we realize, I mean, if we look at it intuitively, I don't think there is. But other than that, like we can't see it, you know? Okay, let me try to do something else. Let's keep the unit circle. Something that intersects. Maybe what if we make this one? Maybe we can move it up a bit too. There we go. That one does look like it works. Then my other one would be something like putting it somewhere above here, maybe. So a center of one. I don't know, just to make it look nice. This one's maybe like what, like two? And then my radius is one. That one looks like it has a solution. Okay, I think this will work because the radii are equal. What if we were to make it bigger? If we did that. Oh, now it doesn't. 1.5. Oh, there you go. Does it? I can't tell if it intersects in some way. Let me just do this. Yeah. Let's do another example where it, or no, I'm trying to do an example where it doesn't, right? We do 1.5. There we go. Okay. 1.52. Oh, geez. Okay, that doesn't work. Um, yeah, 1.3. This is so random, too. 1.2. Sure, 1.2. Why not? 1.25. Oh, but this one it overlaps. This one we're sure it doesn't. So can we find a circle that intersects all of them? Right? Okay, this one we're actually gonna try and see if we get. I'm just gonna do like another example. Okay, let's get ready. Let's see if we can do it. Um, God, these formulas. They're really annoying, I'm gonna be honest. Oh crap. I think I just let me. I'm guessing I took an hour doing that. Anyway, okay, we'll finish with this example and then I'll move on to the next one, which is we're gonna make it in 3D. At least we have one example here that works. Okay, let me just do this. Uh, I might, yeah, I might just GPT it just so that the computation's faster. Uh, Pretty sure I did some code. Yeah, I know I did something here with the Or no, I totally forgot. Because this one's a new one. Yeah, I know I did something previously. I think it was this one. Oh shoot. Only wrote the okay. That's that's not good. Okay, fine, I'm gonna do it myself. Okay, let me do it myself. So the second example doesn't work because my R is negative, right? So my radius has to be positive. Okay, let me do an example. Three. Okay, so here again, my x1 is 0, my y1 is 0, my r1 is 1, right? The next one, this is 2. These are still the same. And then lastly, this is the one that's a bit different. This is 2. Or I'm kidding. This is 1. This is, God, I wish I had to, 1.2. This is 1.2 squared, right? Yeah, a very random number. Okay, let's actually try and see if this works. So I go again, I go to my y of r. I see what I can do here. Actually, let me just derive everything from a to all of that stuff. So, okay, here's what I'm gonna do. I'm just gonna copy paste and then just plug in everything I know. So that's quicker, right? Because we were able to do it. Yeah, because we're lazy. Okay, x1 minus x2. Well, that's just negative 2. Y1 minus y2. Oh shoot, did I put all y1? Oh my goodness. This is y2, y3. X1 minus x2, negative 2. Y1 minus y2, that's 0. R1 minus R2, that's 0. This is 0. 1/2 of these. Well, this is 1. Okay, let me quickly. R sub 2 squared, so that's 1 minus 1 plus x1 squared minus x2 squared. X1 squared is 0 minus x2 squared, that's 4. Y1 squared, that's 0. Y2 squared, that's 0. Oh, look at that. I got negative 4 over 2. So I got negative 2. Nice. Okay, done. Next. Okay, this one's a bit quicker. It would be nice if there was a formula to do this. Like a really, really convenient formula. Uh, okay. Here, oh, did I take a screenshot? Oh crap, I took a screenshot, didn't I? I took a screenshot. Okay, that's nice. Let me go back and do it again. Okay, here, yeah, after this example, I'm gonna do something else. I'm gonna do the 3D one this time. So my x1, okay, my x1 minus x3, well, that's negative 1. My y1 minus y3, that's negative 2. My r1 minus r3, ooh, 1 minus 1.2, that's negative 0.2. If I'm not mistaken. Yeah. And then my D2, Well, let's just plug in everything. R sub 3 squared. 1.2 squared was that? That's 1.44 minus R1. That's 1 plus X1. That's 0. X sub 3, that's 1. Y1, that's 0. Y sub 3, that's 2. That's 4. Okay. So I have 1.44 minus 1 minus 1 minus 4. Minus 2 minus 4 minus 6. I get minus 4.56. Okay. I think I should have just done it in code. It would have been easier. I could have just calculated. Oh, but what if there were like square roots, right? That's the issue. Okay, done. I got everything. Time to plug in. Let me. Where's my formulas? Shoot, I lost it. Oh, here. Okay, I'm just gonna plug in everything. Right. So this is this one. Yeah. Here, this is my okay. Let me see. So this is A2. I swear that's A2. This is -1. C1 is negative 0.2, right? And so this is 1 times 0.2. This is just 0.2 actually. Okay. A1, C2. A1 is -2 times negative 0.2. So 2 times 0.2, well, that's just 0.4. And then I just subtract these two. Look at that. I get negative 0.2. God, I hope this works. Okay, A2 D1. This is -1. D1 is -2. So I get 2 actually. I get 2 here. A1 D2, -2 times negative 4.56. So 2 times 4.56, 9.12. I could just subtract that. 7.12, right? And then I have A2 B1. That's just 0. Negative A1. So this is +2. B2 is -2. Oh, so I got -4 then. Okay. Oh, crap. Now my eraser doesn't work. I could take out the negatives. That way this just turns into pluses. And there we have it, right? 0.2 R plus 7.12 divided by 4. Okay. What else? Now let's solve my x of r. Because I was able to get nice formulas because the radiuses were the same, right? Oh, I just realized why it will work that way. It is because the radiuses are the same. Yeah. So it is hard to like, anyway. Or at least that's what I know for now, right? So here we kind of assumed already the assumption that their radiuses has to be equal. Yeah, that was the assumption. So I don't think this will work. We'll see. If it doesn't work, then we're going to assume that the radiuses has to be equal. And if we were to try it again, well, yeah, we should be able to. Okay, gosh. Should work. That was the assumption. Yeah. The two conditions are that my r has to be greater than 0. My radiuses have to be equal. Let's try this. Let's see if it works again. C1 is 0. Oh, this cancels. B1 is -2. This is -2. Minus B1. Oh, B1 is a 0. So everything here just cancels because B1's a 0. And so I actually get a number from my x. So A1 is -2. What? Oh, I get 1. I actually get 1. I get a number here. Okay, cool. Now let's plug them in to my R. Okay, let me just do, God, I don't want formulas. Let me do this formula. Yeah, that was the catch though. It should be that their radiuses are equal and my R is greater than 0. Those are the conditions. But here we're trying a scenario where, well, yeah, I mean, my radius shouldn't be negative, right? Because there's no such thing. Here we're trying a scenario where what if the radii are not equal? Oh, let's see. Here we're doing this. Let's try x of r. This is 1. So this is a number actually. X sub 1 is 0. So 1 minus 0 squared, that's just 1. Plus, this is y sub r. Y of r. So that's, oh goodness. 0.2 r plus 7.12 over 4 minus y1. Y1 in this case is 0. So let's just leave it like that. And then this is equal to r minus r sub 1. R sub 1 is 1. So this should be there. And now I think we can solve for this, right? So we can say this is 0.2 over 4. What was that? 0.05? 7.12 over 4, that's 1.78. And I think I can expand this thing. So I get r squared minus 2r plus 1, right? I'm just checking. R squared, negative r, negative 2r plus 1. Okay. And from here, now we can just say, or we can expand this out. Let me try doing that. Zero 0.05 squared, that's this. And then I multiply by 1.78. I get 0.089. I do the same Same thing, so I just multiplied by 2. This is r squared. And then I do this. There we go. Oh, then this is equal to this. Okay. And then from here, I just add the 1. So this just becomes 4 point. Oh, I can actually just subtract the 1 on both sides. Let me just do that. Okay. Then from here, we have this. And then now I can just subtract. What else can I do? I'm trying to think. Yeah, I would just do a quad formula here. Like it doesn't, yeah, I mean, yeah, just a quad formula. So this is 0.0025 r squared minus r squared. So minus 1. Well, that's just negative 0. Let me just actually solve it. 9975 r squared. And then this is plus 2. So 2.178. Yeah, and then this one stays. And that's equal to 0. And I just do a quad formula here. So this is negative b plus minus square root of b squared minus 4ac. Oh, I got a positive number here. Oh, that's too big. That's the issue. I will see. Sometimes it works, sometimes it doesn't. We'll see. The big reveal. This is plus. Oh, crap. It's a plus. Yay. Finally. Yeah, because this one was a mic. You're kidding me. This was a plus. Oh, wait. Negative times negative is a positive. Oh, oh. So that one worked. Oh my God. There are solutions for this works. Wait, let me. Uh, and then this is. Wait. Let me try this other one. 478. Yeah, so this one becomes negative 478. Yeah, and then I just add these two together. Oh, shoot. Wait. How do I? Yeah, that other one works. That's kind of. I think, bro, my solution. Okay, my algebra, man. I just realized, like, after. Okay, that one had a chance. Let me just go down for a bit. Here, let me put it here. Okay, I'm just trying to be super sure that it works. Okay, this is. I think I can get this one to work. 405011 2. Doesn't look like a nice number though. Square root of that, is that like a nice number? It's not. It's like 2012.49-ish. I'm just gonna put that just in case. And then so when I add it, it shouldn't be a but then I have this negative, so that's another issue. But then what if I there is a solution that works here, right? So we have to find the positive solution or the positive R. That's the one that will work. Or actually, we can find all of them because that's just going to be squared anyway. Let me find all of them. So we do this. Let's say we add it. Let's try. So I have this value. I subtract 181 and I divide it by 478. Yeah, so I get like around negative 3.83-ish. Yeah, wait. Let me just do this. So it's either that or the minus one. Let's try both solutions to see if it works. Oh, but then I have to plug it in back here. To plug it back in. That's funny. Is there like a way where I can just put this as it is? Okay, let me try. Type all of these in. Uh, How do I do that? Has to be a way to do it in Desmos. I don't want to simplify anymore. It's too much. Okay, what was my example here? 001 402 402. That was a big number. Then my other one was, I think it was 2, and this was +8. Mathematically, or when I look at it, it doesn't really like make sense, right? Because this one's like all the way at the bottom. Watch it be an ellipse. This one. Okay. So for our circle, right, we're gonna have our x value minus our x of r. So my x of r is gonna be, yeah, well, my r value. My r value is gonna be. Can I add a slider? Is there a way to do that? What if I do like r equals? If I do this, r is equal to this. Let me try that. This is -20. Let me put it at the top just to be super, super sure. This is -478. And this one's plus. Can you do like a plus minus or no? And this is square root. Already simplified it. 4050,112. Yeah, and I get this negative value, right? And then now I put my thing here. So now I have minus. And I have a function. So, oh crap. How do I? Oh, let me do this. X. Can I do that? So here is gonna be my X. Can we add this? Oh, we can do that. Add like a slider. No, this is gonna be like some function of R, right? 2R. Oh, you can do that. Okay, I'm learning. What was that? 2R plus 13 over 18. 2R 8. And this was 13. Oh, cool, nice. Okay. Why is it like that? What the heck? Oh, so I have this number then. Oh, there we go. And I add Y. And I'm just gonna add this big Y. Yeah, now I'm gonna add a Y value here. And I think, yeah, now this is 2R plus or minus actually. And then this is equal to my Radius. Now it doesn't work. That's funny. Or I just messed up the calculation. I don't know. Um, look, that it's like secant here. Or it just doesn't work. It could be that. Um, I don't think hmm. I'm surprised this didn't work. I was kind of expecting it to work. Minus. Yeah. So both of my solutions don't work. Why is that? Well, if you look at their like centers, I think that has to be it. Probably their centers as well. I think. They're really like, oh, 2r minus 4 plus. Yeah. It. Yeah. I mean, we just like put this out maybe, and then r squared. Now it's gone. I think that's possible. Now it's too big. Yeah. So the idea was, I think, or the assumptions, it has to be equal. Their thing here. The radiuses has have to be equal. I think that was the assumption, right? Yeah, that's the assumption. At the end of the day, I don't think this will work because of the, yeah, cool. Okay, that was a big reveal for me. So in other words, this doesn't work because, yeah, I mean, it doesn't. My thing has to be or did I just mess it up? Or no, I don't think I should have, right? Yeah, those are the assumptions. I'm just gonna write it down just to be super clear about what I've realized. So the realization was that, yeah, um, both are, it didn't work. Yeah, let's be honest. Since radii of inner circles are not equal, because we can also kind of see in a way. We could kind of see here, like let's say this was the center, somewhat equal if it's somewhat equal. So it kind of satisfied that. But then again, that was the assumption we're working on. So they have to have the same radius, same distance, right? That was the assumption. Um, yeah, that was the realization here. Their radiuses has to be equal. Um, so even if I try this, I doubt it's gonna work. This looks hopeful though. So I'm gonna continue. Let's see if we get it. This is plus. Let me just double check. Yeah, this is 4 times 0.9975 times 1684, 12.64. 1916. This is over negative 1.995. And so again here, 3684, I add 12.64196. I get this nice looking number. Or at least it looks nice because it's not negative. I don't think it was negative in the first place. Okay, let's try and see if we get it. So I don't think this one's gonna work again. Mainly because of that. The idea being the radii are not equal. So the radii have to be equal. Because that's the relationship we solved for a while back. Yeah. So let me see. You're right to share. There we go. Okay. So this one didn't work, right? What if we make a new one? Oh my goodness, did I switch it up? Okay, so yeah, let me just take it out. Or no, let me actually leave all of them. My bad. We're just gonna replace these with something else, right? Okay. Let me replace, what was it? What were my numbers here? So one's the unit circle. This one was a 2. And then I replaced this other one with a 1. And then, yeah, so you can see those two circles. I haven't, okay, let me take that out. And then for this one, the last circle was 1. And this was -2. And then this was 0.2, right? If it was 1, I think this would have worked. We'll definitely find something here. And then my R value here is, oh crap, what was it? Negative 2 point, oh geez, 2.178 plus minus. So we can do plus first. We're gonna add it to 17.3856. This is over negative. Oh crap me, what did I do? 1.995. Oh, there we go. Then for my X and my X here is surprisingly 1. And then my Y here is something else. So my Y is 0.2 R. And I divide that by 4. And then I add in my numerator 7.12. And well, yeah, I mean, big reveal. Wow, we didn't get it. Yeah, so that was the assumption. The assumption was that my radii have to be equal. Yeah. What if I do a negative then? Oh, so when I do a negative, it kind of intersects the 2 here, but it doesn't intersect with this because again, it's not of equal radii. So it has to be of equal radii. So something like maybe a 1. This one's gonna work, right? We're definitely gonna find something here. So yeah, my assumption was correct. So okay, let's just finish off with actually editing, making this 1. If we make, let me go here. So if we make this 1, then some of our things will change here. So this one should work because yeah, my R sub 3 is, this one's 0. C2 is 0. right? I think that's it, right? What else did I miss? R sub 3. No, this one's a different one. So now this will change. R sub 3 is 1 minus 1, 0, x1. So this is x1, 0, x cubed 1. So this is 1 or minus 1. And then this one is uh, y. Oh, here I get negative 1/2, right? Because here I get 0. This is 0. X sub 1 is 0. Y1 and 3 are, oh no, my bad. Y1 and 3. So this is 0 minus 2. Minus 2. This is 2 squares, that's 4, right? I have negative 5 here. Yeah, so negative 5 halves. And then if we plug that in, or if we simplify, we have like negative 2.5. Okay, let's try this. Um, yeah, let's see. Let's see how well we do. So my y of r is, crap, I totally forgot what it was. My y of r is this. Oh no, that was my first example. My y of, okay, here. My y of r is this. So I'm just gonna plug in everything I know. Well, here immediately I see C1 and C2 cancel, so there's no r to consider anymore. What else? What else? What else? What else? Yeah, now I can just take this out. So I can take this out, right? Because my C1 and my C2 are 0. My A2 D1, negative 1 times negative 2 is actually positive 2. So this is 2. A1 D2, so negative 2 times negative 2.5. I just get minus 5 in this case. So here I get 2 minus 5. I get negative 3. And then A2B1, that's just 0. So I get nothing here. And then negative A1, so that's plus 2. B2, so 2 times B2, so that's negative 4. And so I actually get 3/4, right? I get 3/4 here. Then my x of r, let me see what I get. Yeah, so here's the idea with those. Again, yeah, my things are equal, so it should work, right? Okay, let me see. So again, okay, C1 is, this is just 0. D1 is negative 2, so this is minus 2. Yeah, see how it kind of nicely cleans up when, and then again, this one's 0. A1 is negative 2. Ooh, nice formula. This one's again 1, right? It's 1 again. And then from there, well, we just plug it in to get R, right? So let's quickly erase these. Yeah, the quad formula is going to make it difficult, in my opinion. But that was the idea. The idea was the, the distances. That was like the main thing here. Um, yeah, so those are our two X and Y center of the outer circle. And then my R1, or let me see. This one's 1 minus X sub 1. What do I use? Oh, I use the unit circle. Oh, that's convenient. And this is R minus 1 squared. Yeah, and then I get 1 plus 1, I get 2 equals this, right? And then I just do a square root of 2. Oh, should I do a plus minus? Here I can do a quad formula, actually. Let me just do that. This is 2 equals R squared minus 2R plus 1. Here I get R squared minus 2R. 1 minus 2, so that's minus 1 is equal to 0. Yeah, I could just do some stuff there. I get R. Or am I making a dumb mistake again? I think that was easier. I don't know why I had to. That one was easier. There we go. There we go. And then now I get my R value. 1 plus minus square root 2. So I have two R values here. It's either 1 plus square root 2 or 1 minus square root 2. Well, that's just, I don't even know what that is. Oh shit, it's a long formula. I'm not gonna, yeah, so it's just this. Done. Now let's see which one works. Then I feel like, okay, so that was a very nice formula. Okay, let's see. I'm gonna take these sliders out because I don't need them. For my X, I think I had one, right? I had one. For my Y, I had 3/4. And for my R, I had, well, 1 plus or minus. So I just have to pick which one is it. And there we go. They're inside. They're not tangent though. Oh, it doesn't work again. So uh, I guess at some points it does work. At some points it doesn't. Like here in this case, it doesn't work. Because see here, it doesn't. It's not tangent. I guess there must be other assumptions that we can consider when we're doing this. What other assumptions are there? Um, this one doesn't work. Okay, well that's interesting. I was expecting this one to work. Um, yeah, because it's not tangent. See, it doesn't touch. I do a minus. Hmm. I don't know why that doesn't work. Um, yeah, that one's complicated. This one's really complicated to think about. In some cases, it does work. In some cases, it doesn't. Uh, yeah. Okay, let me actually find something that works. 231 001 401. Has to be a 4231. And there might be a reason why it does work. Oh, look at that. That definitely looks like it's gonna work. And it is also a vertices of an equilateral triangle, and they all have the same radius 1. So I think that's the idea. It has to be that. Yeah, it's difficult to assume. Uh, it is difficult. Like if we were to, hmm, yeah, that's why I realized in today's like research kind of, it doesn't work for most circles. It only works for specific ones. But what's the? Yeah, I'm trying to find like all of the ideas that make it work. 2, 1, and 3. So if I, yeah, so here this works, and then another one works here. If we do 001 401 231. Okay, that's too small. It's an equilateral triangle. They're vertices. And then an outer circle would be 2, 1, and 3. So this is 2, this is 1, this is 3. Wait, what? This doesn't work. That's funny. Uh, that is funny. Well, if we actually do this, will we get like the same answer? Let me just ask GPT to use my formulas. I have like 3 things or 4 things I want GPT to use. Because I don't want to like handwrite it. Handwriting it is way worse. Uh, okay, let me try this. Can I do that? Can I, like, oh, I can't attach formulas. Goodness. Okay. That's not good. I guess I have to wait till next time to do this, I guess. Uh, or does it remember? Yeah, okay. Okay. Okay, it's getting the same thing. I wish I could like submit it here, but then it doesn't work. Okay, I might just do this for another time, I guess. At some points it does work. Like surprisingly, at some points this works, but not for all. Uh, but yeah. Okay. I really don't know how to. Okay, yeah. I'll just wait for GPT to like get my thing ready, and then I'm just gonna do this some other time. Um, yeah, that's really it. I hope you guys enjoyed. And I hope you guys learned. I mean, even I make mistakes, right? Like these are mistakes. Sometimes they do work, sometimes they don't. That's the issue. So if you guys like have any ideas, feel free to. Yeah, but then it doesn't work. Well, I feel like it does something because I did have a Python code to help me, or I can write it in Python. I think I can just do that. I might just write it in Python and then see what happens, right? Can I do that? Uh, Here I have this one. Okay, let me go here because I did write some code for this. Yeah, I should have just used that. Oh no, GPT. Let me go to CodePad and random IDE. Uh, okay. Here's the thing, because I did write it. There's some things here. Then I get values, and then see here it works for that first example. My 10, 0, 10. Or no, this one's 60, right? Let me try this. Okay, let me just write it in code because I feel like I'm gonna actually, yeah, this one I'm gonna do for the next video, right? So this one was like a total realization video that I didn't know. Next time I'm not gonna like solve it. I'm just gonna write it out. But yeah, I hope you guys enjoyed, and I'll see you all in the next one.